Hi everybody. Just wanted to start the class off by just looking through the homework together. So problems 1 and 2, super basic, and we gotta really take the time to make sure we got these identities, these rules down, so we could kind of work interchanging here. All right. So tan becomes sine over cos, and we can cancel. All right. Cotan becomes cos over sine, and we can cancel that. And problem 3 has a little bit more going on, where we have 3 pieces. And one key rule I always think is if I can make things in the sine and cos, so problem 3, first it's cos, tan, and cosecant. Well, by making it to sine and cos, I've taken it from 3 different trig functions down to just 2. So having more similarity between your work usually tends to make things go a little bit better. All right, problem 3 brings on, I guess one thing about problem 3, I was talking to some people in the other classes, you have options. You don't have to do it exactly the way you see me do it. Some of the other class came with this amazing option. They said that if you bring up the sine, that becomes cosecant squared x, and that means cosine squared divided by sine squared is cotan squared x. And know what? That's one of our rules. Cosecant squared x minus cotan squared x is 1. So I just really want to get the idea out there that do what works. Do whatever you want. Right? As long as you just do something, it'll mathematically work. Now, what I did for problem 4 was I noticed I had a common denominator, so I was able to add them together. I realized this is like 1/4 minus 3 over 4. We got 1 minus 3 over 4. We bring that common denominator of sine squared with us, and then we have whatever we have in the numerator. Now, using our identity rule, sine squared x plus cos squared x equals 1. Well, know what? If I subtract over, sine squared x equals 1 minus cos squared x. And that's what gets played into here right now. All right, problem 5. There's an option. All right, so this option works. There's other options. So another option is we could treat this as if I move the secant down, right, the secant becomes cos x. I still have the cos x up top, and I could bring the cotan up, and it's tan x. Well, right there, just by moving things around, cancel, I have tan x. So there's many ways to do these problems. You just have to find what kind of works best for you. Down here, problem 6. This is upper level, right? This is what we're working towards. All right, so these have a few rules are going on here. Rule number 1 is from here to here. By doing this, by changing it, now I have a common denominator of sine. By having a common denominator of sine, I'm able to take my denominator and make it into one piece. Now, I didn't show this step, but really what just happened here is then I took this and made this sine x divided by 1 minus cos x over sine x, which due to keep change flip, we get this. Right, so the first key rule going on here is, we use that common denominator. So then when we multiply, we get sine squared. Well, same as the problem above. Sine squared is 1 minus cos squared over 1 minus cos. Now, this is a rule we're going to learn about in a few days. But we can factor. So we talked about factoring before break so we can get our factoring skills back together. If I think about it like this, if I just said y equals cos theta, I could think about this as 1 minus y squared over 1 minus y, which if I factor, I'd have this, which leaves me the opportunity to cancel. And if I'm left with 1 plus y, I can sub back in as 1 plus cos x. So one thing we're going to talk about later is this factoring rule. And for the moment, don't think too much into it. We're going to come to it later on. Right, so I just wanted to run through the homework, give you a chance to look at it, and then touch on some new ideas. All right, so look at the do now. Just talking through some ideas. So I see this problem here, right? I know I got my identity rule going on. So my first identity rule is, right, we have the rule, 1 plus tan squared x equals secant squared x. So I can make my numerator secant squared x over cosecant x secant x. All right, fantastic. With this done, cancel, cancel. So now I have secant x over cosecant x. Right? What can I do now? I can move up my cosecant, and when I move up my cosecant, it becomes a sine. I can move down my secant. When that comes down, it becomes a cos. So sine over cos is tan. And this is one way to do it. And as I walk around the room with my other class, I saw multiple things going on. Right, so whatever works for you is fine with me in these scenarios. All right. Looking at my next problem, I got another rule going on. All right. So here I got 1 plus cotan squared x equals cosecant squared x. All right, so if I subtract over the 1, that means that cosecant squared x minus 1 equals cotan squared x over cos. All right. Well, you know what? I can bring up my cos. All right. So if I got cotan squared up, I can bring up the cos. I got cotan squared x secant x, which gives me cotan is cos squared x over sine squared x times 1 over cos x. All right, well, guess what? Do some canceling. Cancel, cancel. So now I got cos x over sine squared x. And this is kind of weird for people. Right? People are very used to like the idea of we combine things. We combine things and make things smaller. Well, know what? I can rewrite this as cos x over sine x, sine x. I separate that. I got 2 sines in my denominator there. Right, so that gives me the chance to bring this back up, which gives me cos x over sine x with the cosecant. And guess what? What's cos over sine? Cotan. So there's my answer. All right, maybe you have a simpler way, maybe something worked quicker for you. I just went with that way, and that's what kind of happened for me. All right, so again, new rules. We need new rules. Common denominator to combine terms. All right, so we need a common denominator to combine our terms. So if I start this problem off, tan is sine x over cos x. Cotan is cos x over sine x. So at the moment, we really don't have much going on. So if I wanted to get a common denominator, I can make my common denominator cos and sine. So I'd have to multiply by cos x over cos x, or here I'd have to multiply by sine x over sine x. By doing that, now I have my common denominator. So I have sine squared x over sine x cos x plus cos squared x over sine x cos x, which is exactly what I want, common denominator. By doing that, I can combine. Now, one thing that stresses people out is you just gotta do something. Do whatever works for you. Try something out. It may not work. Right? I look at people's work all the time. Some people do something in 3 steps. Takes other people 5 steps. Well, what's my key rule here? Key identity rule. Sine squared x plus cos squared x equals 1. So subbing that right in, I got 1 over sine x cos x. If I move up the sine, I move up the cos. Cosecant x, secant x, done. And that is all made possible due to having a common denominator. All right, problem 2 over here. I could take the same route to start, but I do realize I could bring the secant down. If I bring the secant down, I have cos x sine x minus sine x over cos x. So I got it almost similar, right? So I got a cosine and then I got just a cos. So this would need a sine over sine. By doing that, 1 over cos x sine x minus sine squared x over cos x sine x. 1 minus sine squared x over cos x sine x. Alright, what's my next move? Well, 1 minus sine squared x, if I modify this, would be cos squared x. So I got cos squared x over cos x sine x. Cancel, cancel. Left with cos over sine, which is cotan. Done. Alright, so one thing we have to make sure we're okay with a lot of these problems is just being able to do the basic math, being able to function with our algebra skills. That's really essential for what we're doing. Now the problems you're going to work on next, not all of them talk about this new rule about common denominator. If we look at our first problem here, so I look at this one, I got tan squared x up top, and know what? I got my rule. 1 plus tan squared x equals secant squared x. Okay. So then I could bring up the secant, so I got tan squared x comes up into cos squared x. Well, tan sine squared x over cos squared x times cos squared x. Cancel, cancel. I'm left with sine squared x. Done. Right, and that's one way to do it. I saw someone in the other class looking at making this. They took the numerator and they changed the numerator and made that something else. Right? You do what works for you. Whatever works, it's going to get there in the end. All right. Cosecant sine minus sine. Well, this one we need a common denominator. So I multiply by sine over sine. That gives me 1 over sine x minus sine squared x over sine x. Common denominator combined. So what do I have now? Well, I got my rule still. So I keep going back to my identities. Cos squared x plus sine squared x equals 1. So if I move this over, 1 minus sine squared x is cos squared x. Alright, so if I take this and pull this apart, alright, so I need this. And what I think is sometimes you can't work with the left side, but you could think about it. Well, know what the left side is? Cotans cos over sine. Right, and we have that cos. So really, this becomes cos squared over sine, which that's what I have right there. Great. So a weird idea is I could separate the cos x into two things. And by doing that, right here, there's my cotan. So I get my cotan x, cos x, and I'm done. Alright, what other ones should we do? I'm looking for some more good ones. We got another common. We got a common denominator one here. This is very similar to one we did before. All right. Well, 3, 4, 5, and 6. I think they're all pretty good, pretty straightforward. And I think using the rules that you have on your paper should help you out through those. So I'm gonna jump to the next rule. And listen, I know I'm not here. That's why we're watching this video. So, we'll cover this. We'll make sure we're okay with this, and we'll be good. I promise. So our second rule is use the conjugate to build the equation up. So what is the conjugate? The conjugate came into play when we had things like 1 over 1 minus rad 2. The conjugate was multiplying by 1 plus rad 2 over 1 plus rad 2. That's the conjugate. And all we do with the conjugate is just change that middle sign. So if I were to use the conjugate here, well, the idea is if we're looking at this side, there's nothing we can do, right? There's nothing we can do. There's nothing squared, right? With the 1 plus, right, we can't move up just the cos, right? So we're pretty limited. So by using the conjugate in this situation, we multiply by 1 minus cos x over 1 minus cos x. that makes my numerator 1 minus cos x, followed by 1 minus cos x plus cos x minus cos squared x, right? Because we had the FOIL. It's a terrible looking S. Embarrassed. Cos squared x. All right, and with that, my two middle terms cancel out. So I got 1 minus cos x over 1 minus cos squared x. All right, well, what does that mean? Guess what? There's one of my identities. All right, the same things over and over again. 1 minus cos squared x equals sine squared x. All right, so again, what should we do? Well, you know what? If I look at this, right, if I think about this a little bit, cosecant is 1 over sine squared x minus 1 over sine x, and cotan is cos x over sine x. So that's kind of what we have here. So what we can do is we can unsubtract. Right? We could separate it back. 1 minus sine squared x minus cos x over sine squared x. So there's my cosecant squared x. And what I need to realize is that I could separate the sine. And by separating the sine, I'm able to combine this and make that into my cotan. So I have cosecant squared x minus cotan, not squared, and I bring the sign up for cosecant x. Alright, so there's my conjugate idea. Alright, what other ones should I talk about right now? Well, a lot of them are very similar in this worksheet, and I think, using the examples I did, using the homework, working through the answer keys, looking it over, and helping each other out, I think we'll be in a good spot. Right? We really don't get overly complicated. So in class, work on this worksheet, try the examples out, check the answer key, and then you'll have a homework worksheet due next class.